first thing you have to do is recognize the problem. And how will you recognize it? Within the body of the problem, you'll find some mention of an integral function. And there will be a picture of a graph. Those two things together mean you're going to be dealing with the fundamental theorem of calculus. Now the strategy goes like this. It almost always comes back to, hey, these are a bunch of simple shapes I can deal with. So I'll say, let's find the areas of all of these regions. Write them in. And then we're going to find the derivative of the integral function and claim it. I mean, we're going to write down what the derivative is. Then we're going to find the second derivative, which by definition is the slope of the first derivative, and we're going to claim that. We're going to write it down where it's visible for whoever is reading your paper. Then, like we do with all derivatives, we're going to do a sign test on the first derivative and a sign test on the second derivative. And when we're done with that, then we'll worry about answering their questions. So before you even get your feet wet as to how am I going to earn points, there's a few things you have to do. Recognize it, label the areas, find derivatives. So let's take a look. I've got a picture of a graph. They're telling me this is the graph of f, but they're also telling me g of x is the integral from 0 to x of f of t. Those two things together tell me this is about the fundamental theorem. Now you might note they asked me for g prime of 4. They're going to ask me for the derivative of this integral function. So take a good look right here. Tell me the derivative of g of x. The derivative of g of x turns out to be f of x. So g prime is f of x. Found the derivative and I wrote it down. I have made that claim. Which means technically I can go over here and say, no, this is the graph of g prime. Now, if g prime is f of x, what's g double prime? Pardon me? It's f prime. So if g prime is f, g double prime would be f prime. I've simply taken the derivative of each of those. All right, now the next step, let's run our sign tests. Here's a picture of g prime. It starts at -5, it ends at +5. Where does it equal 0? -4, -1, 1, and 4. Now what do the signs on my sign test for g prime look like? Negative, then it goes above the axis for a while, it's positive, and it goes below the axis from -1 to 1, then it jumps back above the axis from 1 to 4, so we're back to positive, and then from 4 to 5 we'll be back to negative. Tell me about g double prime. Now let's keep this phrase in mind. G double prime is just the slope of g prime. Initially the slope is positive, that's on its way to -3. Then from -3 to -2, the slope is actually 0. From -2 until I get to 0, the slope of g prime is negative. Then the slope goes back to positive, and the slope goes back to 0, and finally the slope goes back to negative. So this is a picture of the derivative of g, and from that picture I can tell you where g is increasing and decreasing. I can tell you where g is concave up and concave down, and I can even tell you there are portions of function g where there is no concavity. All right, now I left off one thing. We should be taking a look at some areas. What's the area of that little triangle on the left? -1. It's 1, but it's under the axis, so we're going to go with -1, then a 1, then a 2, then a 1, then a -1, another -1, a 1, a 2, a 1, and a -1. So now we have done those 5 preliminary steps. Declared our derivatives, done our sign test, found the areas, recognized that there's an integral function and a graph. Now it's off to the races. Find g of 4. Let's see here. G of 4 would be the integral from 0 to 4 of function f. I'm just adding these areas together. -1, +1, +2, and 1 gives me a total area of 3. That. Yeah.
I thought that graph was G prime.
It is.
Then why can we substitute 4 in? Oh.
I substituted 4 right here for that x. And so g of 4 turns out to be the integral from 0 to 4 of function f.
Oh.
All right, here's an even easier question. Find g prime of 4. 0. This is a picture of g prime. Right there is g prime of 4. That turns out to be 0. G double prime of 4. Negative what? -2. Abby, how did you get -2? You're just looking at the slope of that line, aren't you? And that slope is -2. So all that preliminary work probably didn't earn us any points, but we probably just got 3 pretty easy ones. And our goal on any of these free response would be to get a good 6 or 7. Tell me part B on this problem. I don't have it on this thing. Does G have a minimum or maximum at x equals 1? Maximum, minimum, or neither at x equals 1? Tell me the answer to that. Minimum. Justify it. That's it. That's it. G prime changes from negative to positive at 1. That's all you need there.
Do you need to, if you did a bit rather, you not say negative and say like less than 0?
They don't care. They actually prefer that less than 0 notation. As a reader, I'd much rather see the word negative than I prefer that. Go ahead.
Oh, no.
Lauren?
When you are writing that, you have to say like G prime of x.
No. G prime and G prime of x mean the same. That's like saying Lauren or calling you Lauren Weber. It's, you're the same person regardless of what I call you. All right, let's go to the next one. This was from 2005. It's question B4. I first note that there's a graph of a function, and soon after I spot an integral function. And that tells me I know what this is. This is that fundamental theorem of calculus problem. So let's go in the right order this time. Let's get some areas. Let's find the area of this trapezoid, a couple of few triangles along the way. I want to say the trapezoid has area -7.5. Is that working? Mason agrees. So the trapezoid here, -7.5. And then I think the total area in each of those triangles is 1, isn't it? So we'll just put signs with them. -1, +1, +1, and -1. And then let's take a look at our integral function. G of x is the integral from -4 to x of f of t. Tell me g prime, f of x. I have found g prime. I've declared that this graph is now the graph of g prime. And if g prime is f, what is g double prime? F prime. So I've declared my derivatives. Next, let's do a couple of quick sign tests. My interval goes from -3, 4. -4, good catch. So from -4 to 3. And where does g prime equal 0? And what signs, this is g prime, I should label that sign test. What are the signs that go with this sign test? Negative, positive, that didn't work out. Negative, positive, negative. And then let's talk about g double prime. Again, the interval is -4 to 3. G double prime is the slope of g prime. So that's going to go positive until you get to 1, and then it goes to negative. All right, now let's answer question A. We can do this. God, darn it. Find g of -1. G of -1 is the integral from -4 to -1 of f of t. How much area is there between -4 and -1? -7.5. Find g prime at -1. -2. G prime of -1 is actually f of -1, which turns out to be -2. And then here's the really good one. Find g double prime of -1. That fails to exist, doesn't it? What does part B in this question ask for? Find the inflection points for function g, and you have a second derivative sign test, don't you? So that's a slam dunk. How many inflection points does it have? 1. Where is it at? Is that 1? How do you know that's your inflection point? G double prime changes from positive to negative. So again, I think we probably just earned the first 5 points in that question. Finding these 3 values and locating the inflection point and explaining the inflection point probably gets you 5. Okay, let's do one more together. Again, I notice this thing starts with a graph and mentions an integral function. Let's get some areas out of the way here. These two little triangles both have an area of 1. The trapezoid that stretches from x equals -3 to x equals 0 has an area of 4.5. The two little triangles on the right have an area of 0.5 and -0.5. And then those two curved regions. You got to do a little thinking on those. To find the total area of those curved regions, what I'm going to do is I'm going to take the rectangle and subtract out the semicircle. And they did tell us it is an actual semicircle. And I can tell that the radius of this semicircle is 1 unit. So the length of that rectangle is 2, the height is 1, so we've got an area of 2. What's the area of a circle with radius 1? Pi. So what's the area of a semicircle with radius 1? Pi over 2. So these two shaded regions together have a total area of 2 minus pi over 2. Assuming they're identical, which they are, aren't they each going to have an area of 1 minus pi over 4? Not sure if we're going to need that or not as we go through this problem. G of x is the integral from -3 to x of f of t. What is g prime of x? So I would immediately go right up here and I would scratch this out and I would say this is g prime. And what is g double prime? Really important that you put that claim down. Write it on your paper. Don't just have it in your head. Go ahead.
For the first triangle on the far left.
Uh-huh.
On the far right.
Should be negative.
Oh, okay.
Yeah. Okay. How about the sign testing? G prime. My interval is from -5 to +4. Where does G prime have its roots? -4, 1, and 3. And it appears to go negative, positive, positive, negative, like that. And by definition, G double prime is nothing more than the slope of G prime. Slope of G prime starts out positive on its way to -3. It goes to negative all the way until 1, and it changes to positive on its way to 2, and then it goes back to negative. And now it asks questions that we can answer. Find G of 0. G of 0 is the integral from -3 to 0 of function f of t dt. That turns out to be 4.5. Next it asks for G prime of 0, which is really just f of 0, and that value is 1. Again, I didn't copy all the pieces in, but I'm going to predict this one asks about either extremes or inflection points or both. That's for both.
All the way down to D.
So find all values in the open interval where we would have a relative maximum. Where would the maximums be? Keeping in mind they're not including the endpoints. They said open interval. Where would we have a maximum? 3. Where G prime changes from positive to negative. And then where do we have points of inflection? Negative 3,
1 and 2.
1 and 2. 3, 1 and 2. So, and we can justify those by saying G double prime changes sign, therefore G would have a change in concavity. So the points are not all that hard to earn. Just have to recognize the problem. Go ahead.
How do you do part C where it says find the absolute minimum?
How would you do part C? We're not quite ready for that. I'm going to talk about that hopefully tomorrow. But what we would do is we would run something that's called a candidates test. Where do extremes occur? I know the answer to this. Endpoints and critical numbers, right? So what we would have to do is say, all right, we've got endpoints at -5 and 4. We've got critical numbers at -4, 1, and 3. And to find the absolute minimum, we would just calculate G at each of those 5 places and then choose the smallest one. If it's got an absolute minimum, it occurs at one of these 5 locations. And because I found these areas, I can calculate G of -5. G of -5 would be the integral from -3 to -5. I think that might be 0. I can calculate G of -4. That'd be the integral from -3 to -4. I think that value is -1. I can calculate G of 1 by adding this trapezoid to this little half moon thing. I can calculate G of 3 by adding in some more. So I can see what those numbers are and then decide, is it a maximum or a minimum? Minimum. Pick the smallest one. Okay. Your assignment for tomorrow. Recognize the problem, claim your derivatives, write in the areas, do the sign tests, and do part A for each of the remaining 5. Get the strategy down. Graph integral function. I know where this is going. Look at the areas, make the sign tests, answer part A. Yeah.
If we look at the other parts and see that we could answer that.
By all means, because we're going to do the other parts tomorrow. That's what tomorrow's lesson will be. Talk about parts B, C, and D, or whatever they might be. But for now, I want you to get the part A's out of the way.